I'll go through. I tried to grab some slides I thought were most relevant to the topics I listed for this event. I talk too fast and I try to cover too much, so bear with me. That way we'll get through it more quickly. This is what I want to do. We have this boom market, we've got all this wood, we've got incredible technology. How do we make this region one of the leaders? And I'm not nationalistic. My wife is from Finland, just got a green card last month from Finland, fresh off the boat. I work with Stefan from Switzerland here. He's been in North America for about a dozen years. And what I want to do is bring in global best practices and make our region a leader in digital fabrication. We've got a lot of reasons we should be doing it, primarily in wood, but also in other materials. This is what makes me sad. My grandfathers on both sides worked in the wood. My dad is 79 years old and he's from Michigan running a mill. He loses money on every project, so I tell him not to grow. But this is essentially what we're doing right now. We're exporting a lot of raw timber and sending it overseas. And so how can we use technology to be more like Switzerland or some of the countries that are adding a lot of value to the material by using technology? That stuff on here, I just put this side in. He runs a factory in Portland. He also gave a keynote, I think, in June at Frame, Australia, about what they're trying to do with timber. That's an entire presentation. I won't obviously go through that. We don't have time for that. But this interest in mass timber and prefab and wood is global. There's a real boom going on, not only in the global construction markets, but the move towards technology. This is what I like to show people. You people all know this, but I do for people who don't. Production of wood, we're the biggest. Consumption of wood, we're the biggest. And Pacific Northwest, here's a bunch of reasons why we should be the leader. In the world, strong economy, a lot of tech. We've got all the forests, the biggest ones. And Oregon and Washington are the biggest softwood producers in the nation by far. And if you add BC in, British Columbia, this is the biggest productive region for wood, so shouldn't we lead in using technology to create beautiful buildings?
Quick question, which species of softwood? Which species is the biggest? Is it like spruce or something? Or
Fir.
Fir?
Okay.
Thank you. Side question, yeah.
Okay, so that's kind of my objective. This is what freaks people out. I've been in Europe for a month 3 times in the last year. And the Nordic regions, saw this from Finland, obviously they build a lot with wood, except for maybe Denmark. But in a lot of the European countries, they're building not with wood. It's maybe like 10% of the standard market. We're 90%. So when I was just in Munich in April, they're like, you guys, we have a hard time culturally convincing people to build with wood. You guys your market's dominated by that. We don't understand why you're not leading the world.
Yeah, but there's a big difference there between residential market and commercial market, right?
You've got a room full of experts to answer that question.
Well, I would say, especially since for the longest time we've had the 5-story regulation about no structural wood frame building over 5 stories. So essentially, commercial applications were cut down and was not available. But yeah, in Europe and places, they've got a lot of history behind different residential constructions. But I think here, we're all stick frame building houses. We're not doing anything with wood in commercial. And in Europe, it's gone a long way, a different way in the last 10 years, especially with CLT.
Isn't CLT against code in some of these cities here, like Kirkland?
Not anymore.
Because you have to have the open wall inspection.
It's changing. It's changing.
When did?
But you're right. That's the big. That's like the big hurdle. That's the big hurdle.
Well, also I wanna. For where it's for, but 90%. That's great, but most of that 90% is chunk stick frame homes, built on site in the rain with really low grade lumber. So and that's kind of for me what I saw in Western Europe. People buy a wooden house, they're proud of it because they get a high quality house and it's built to exceed a concrete wall house or a brick house. And here, if you ask 10 random people on the street that are not familiar with that, they would buy a stick frame house or a wood house because of cost. But if you say you can have same price and have a concrete house, a brick house, or a 2x4 or a 2x6 house, they would probably not go for a wood house. So that 90%, a lot of that is chunk too. It's like, there is the good
You're
buildings.
standing in Ballard, one of the biggest growth places in Seattle is building those crappy ones.
Yeah, and that's fine, and there's a reason for that. I don't say that's all bad, but 90%, if you really look about, quality built wooden houses and stuff, that's not 90%, and it's a lot less here than in Europe or in Australia or New Zealand for that matter.
Yeah, and ultimately I think we talk with Stefan, and I have good friends who are in the metals fabrication business. Think of Bill Zahner, who did the Experience Music Project, and composites people, and even concrete people. Ultimately, I say digital fabrication prefab is material agnostic. To me, it's not concrete versus wood, it's analog versus digital. It's using technology to build better regardless of what material you're using. So I've talked to the Tekla, the steel guys, and I came in there like, you're the wood guy, why are you coming to our meeting? And then I heard the presentation, and I'm like, I can use your presentation. I only have to change 10% of your presentation, and I'm saying the same thing. And their presentation was in Portland a couple of years ago. They said, if you structural steel manufacturers don't start integrating your BIM, CAD, CAM, CNC, and using a lot more CNC, you're all going to go out of business. Because other countries in the world are adopting a lot more technology, so you can't compete if you don't go that direction. And I said, I'm bringing that over to wood, and I'm essentially saying a similar thing, because I think it's the best way we can build better, faster, cheaper, and it's all technology driven. So I'm not, and most buildings are hybrids. Almost every wood building has concrete and a lot of metal in it. So I don't feel I'm in a materials war. This is CLT. A lot of you know what that is. There are people here, and it's starting to be produced here. There are going to be more and more producers. And Forterra had a great conference in Tacoma in October with about 200 people. And it's wonderful. There's a lot of support for CLT, but to me, CLT is great, but it's just another wood product. All of the value add and job creation should go what you do with it, how you fabricate it, how it becomes a building. And to me, there's not enough discussion of that, because that's to me where the real opportunity lies. People have different opinions about that, which is great. But I think you want to learn from the European experience. Stefan, these are just some of the CNC machines. Maybe I'll have you chat briefly on that.
So top left is a new cruising machine. We run a cruising machine, not that one. So this is like a
Wait,
six.
you have to get in front of the camera.
There you go. So, I mean, in general, just real big picture for
Over here.
those people that are
Over there.
Right here. Behind the podium.
Yeah, the podium. All right, there we go.
Is that good?
All
So those machines, for like real big pictures, what it is, we have a 3D model, we create a digital shop drawing being a machine file. It's basically a coded shop drawing, and then that machine starts to move one way or the other, and it goes through a bunch of different softwares. So most of the stuff that you probably, if you just ask a random person about CNC, they're thinking like routers for the furniture industry, that kind of stuff. So on the heavy timber and the wood side, we have a bunch of different machines. So the most common is this is a joinery machine, a beam processor. So we can run beams on this particular machine up to like about 12 inch by 48 inch wide, and then as long as you want, because it's a linear machine. We have mill heads, that's basically a planer head, finger mills. We have saw blades from top and bottom. And so this is kind of what I do, trying to figure out, this is what I want, how do I do it? Do I use a mill head or a saw blade? And the more of those things you have on your machine, the more complex it gets. It's almost the more tools you have, is like, do I use a screwdriver, a hammer, kind of a deal. So we do that. This is down at D.O. Johnson. This is a Handegger TPA, a gantry machine, a much larger machine. Just to give you an idea, this is about probably 20-some feet wide. The whole machine moves. So this is a stationary machine. The beam moves around. Here it's the opposite. You put a panel or a big beam on a table, just randomly just throw it on there, and then there's lasers on the machine. You scan it, you give a reference point, and then the machine runs over it. And essentially, you don't see in here, but the same stuff is happening there. So this is like a bridge crane. There's a big gantry up there, and then on top you have a saw blade, you have drill units and mill units, and so on. So that's kind of, this is a Cruiser, it's a Swiss machine, and that's kind of interesting to me too. If you look at the mill industry, and there's people that know that a lot better than I do, but most mill machines, the laser stuff is some of this Italy, a lot of it is from Japan or Europe, and the wood industry, pretty much everything's from Western Europe. So this is a Swiss machine, this is a German, there's a bunch of Italian brands. For some reason, nobody in the US is building a machine like that. I don't know why that is, and yeah.
Down this question, why not do it the way the automotive industry does, with a whole bunch of quota arms and just throw toss it, lock it?
Coming.
Say again?
That's coming.
Okay.
There's two things. Essentially, this is the same thing. It's just on a gantry. Some of those newer machines got up to 6-axis. The robot's gotten a lot cheaper. The problem with the robot is how you talk to them. So there used to be issues with repetitive accuracy and stuff. That's not an issue anymore. The big issue, and I could talk about it for 2 hours. We've done a lot of testing. We have a robot in our shop not working. Hopefully there's going to be a working one coming soon. There's a bunch of things. So for one, this whole movement, that's part of it. But we're also, if we're running, let's just say we cut 1,000 drafters, they come in at that 1 a minute. So besides this whole deal, there's also a whole handling system, in feed, out feed, pulling it, and so on. There's certain advantages of having a gantry versus having a robot on the track. And right now, really the biggest bottleneck is the flexibility of the coding. You can't just, here we can, within minutes, we can transfer geometry to a machine code file. And with the robotics, that's a little bit more involved. This is, this is more a use about kind of, you program a piece once, and that may take you a day to program it, but then you do 10,000 times that piece. But I don't know, in our shop we never have that. If we have 10 parts that are all the same, that's great. And that's mostly only because the drawing wasn't done yet, and then they come in with the whole here and the thing there. So we have, each component is a prototype. But with that said, I mean, just to give you a rough idea, both those machines are $1 million plus. Like this is 1 point something, and so is this. And a full-blown PPA can be $2 million.
That's why I asked the question.
So a regular robot, you're looking at 100-some thousand, and even if you have that also, so those robots would actually work out better financially. So for all the tech people, if somebody wants to come up with a good software like the Revit, the robot language CAM deal.
Using G-code for this, or is it custom code?
This
Well, it
thing-
has to be.
Well, kind of. This is all internally. So I don't want to get it too technical, but we use out of the geometry, use a file. It's basically a process definition where we address each process. It's a detail of EVX. It's an XML-based deal. And then from there, it's a cheat code-like type. Again, the more stuff you have, the more involved it gets. There's processing strategies now. It's not just the positioning things. It's like, well, if that lap is up to 2 inch, I use this tool. If it's more than 2 inch, I use that tool. And
Right.
just like a good
You need
craftsman.
some sort of machine learning in there, or
Yeah.
or a person that knows what they're doing.
That's what they have.
And then also what's happening here is a dynamic thing. So the tools are moving, and so is the wood. So it's kind of that. But again, I could probably go on.
Sorry, we're just speaking out of the circle. I love it.
Well, and I think,
What's fascinating here is, and I've been doing that for the last, like almost 20 years now. Like I started with the very early hand diggers, and the machine itself, it's still the same. They look a little flashier. We have more heads now. They're 5 and 6 axis. Before it was 3 axis and then 4. But really the big step was all software. And even on our older machines, it's like we can do so much more now with an old machine just by having new software.
At the risk of derailing the conversation,
Yeah.
you glossed over something a minute ago. You said something, the drawing wasn't done yet. And I would say that that's really the problem. The problem is never one of technology. Because if we figure out what we want to cut, we can figure out how to cut it. But we have to know what to cut. And we have to start by designing to the capabilities.
Yeah.
So if the technology can do new things, should we design in new ways?
Can I step in on that one? I would completely agree with you, David. And every place I've worked with, I've been in CNC fabrication with Hundegger and heavy timber and various things since 2001. And in almost every shop I go to, design is the bottleneck. There's no question that getting an accurate 3D model completed that works in the field is like one of the most difficult parts of the process. However, you can't ignore what he's saying. It goes both ways. I've plenty of time had someone come up, it's like, well, this is what we want to build. This works great on site. The engineer's happy with everything's good to go. We're like, well, we can't cut that. That has to be hand cut. That's going to add cost. It's going to add hours. And then all of a sudden it goes back to design and that whole thing.
Yeah, it's that mutual knowledge. Designers need to know
it goes back and forth.
how it's going to work.
It goes back and forth. And as well, if I
I'm
could,
gonna
as
jump
long as
in.
I know.
I'm just like, you mean, as an architect, I produce a product. My product is actually used by not the hospital owner or the doctor, but the product I produce is used by a trade sub? Why would I want to talk to a trade sub? I have lots of meetings with the doctors
They're
and the
cool
nurses.
though. They really
Well,
are.
I'm being facetious. I love to talk to trade subs. I learn tons from
They're
trade
fun
subs.
to talk to.
But that's one of our big problems is that we see our users as the end user of the product. We don't see we produce an intermediate product. What you do with my documents at the end of the job, you throw things away. We all take a picture of the building. Why am I not talking to the person whose hands are dirty and cut and
The means and methods are not your problem.
Yeah,
And
but they need to be my problem.
They need
For
to-
this to
right,
work.
they need to be, because it's like, I don't know if any of you guys are aware of Structure Craft. Big company in BC, they do a lot of this type of work, and one of their problems is that they are engineer driven. I'm probably stepping like shit in big trouble here, but if everybody is an engineer, then they look at every little joint and they engineer it to be perfect, right? And if you stop and you say, you know, if we over-engineer this one, it'll apply in 37 places, and we don't have to have 37 different designs. That kind of interplay between design and production is really what makes this kind of thing work.
Here, here.
At every modular construction event that I've ever been to, sort of the biggest takeaway out of the entire thing is that you cannot do modular if you don't do design build.
Why?
Because the design that's done in isolation
It
does
can't
not
be-
take into advantage.
Feedback loops.
Yes.
The learning has to have these
You have to have
standards amongst.
Conflict between intent and actual.
Yeah. And the only way to get people to talk is if they sit in the same risk pool. If we're all sitting in the same kiddie pool.
Yep.
What's that new company? There are two people here at this meetup from it. They're doing that right now.
Katera.
Katera, yeah.
Or blockable.
Yeah. So they're out there, but you have to be in the same risk pool. Then if I screw up my design and I want to wear black and funny glasses and think about it some more, hurts you in the field, it hurts my bonus too.
No, I totally
So,
get it.
it's
I
just-
believe VI will work, vertical integration.
So if you solve all your problems in the design, in the CAM, CNC it out, Lego block it together in the field, how do you mitigate against things that you can't anticipate in the field?
It's, well,
Like
to be
what?
true, we have to be thinking not only of
What
design
are you
build,
trying to-
we have to be thinking
Flexibility
of,
in
we have to be
between what is
thinking,
designed and the actual as-built.
yeah, we're living in an incrementally delivered, highly iterative world. Architecture needs to be DevOps. We need to be, we develop, and we do it, we just don't call it that. We develop an early site package and we release it. It's in construction, it's in the field, I'm developing the next package. We have to be thinking, however, that I'm supporting one package while designing the next package, and then supporting two packages while designing the third package. Yet we take our CA staff and we pull them out and we go put them on the next design job. And we leave one person alone to handle it. And if any software company did that, they'd go broke. But we do that all the time, and we do it with the millions of dollars the contractor is risking to build the building. But anyway, we should move on.
Doug, you say, how much of this parallels your experience? Doug.
Doug?
Well, yeah, we're design build in a lot of what we do, and for us, a
a trade hour and a design hour, we can dispatch either. And so we can say we want 10 more design hours because it'll save 100 trade hours. So we can make those trade-offs in a single contract, and that's part of this risk.
Yes.
rule idea.
How close do you get to 0 trade hours?
Well,
Trade
I think
hour.
it's interesting, we did a project with Genie Industries in 1999, and the person that ran their production said, for 8 quarters in a row, I asked for 10% more production out of their plants in Redmond because their international sales were going up. And he said, every quarter I got 10% more production, and my cost per unit went up because they used the same process to give me 10% more. And so the 9th quarter, he said, I asked for 40% production increase in 1 quarter, and I didn't tell them why. Then they said, well, then we would need to, and they already knew how to redesign the lines on the floor, but nobody ever asked them for a dramatic improvement. They asked for incremental improvement. And so I think on projects, we look at them as, we wish owners would ask for the building in half the time, because if they do, we would ask for more architect time, and we would create a phase for a manufacturable drawing, not just design is done, trades figure it out. I mean, we don't ask the right questions to accomplish speed of delivery. We just let each segment of delivery do only what they're asked to do. And that's only incremental improvement instead of dramatic.
And just a step back without going too deep technically, if I'm looking at wood and CLT mass timber, when I originally researched all this as a builder, and I went and visited Structureland and a lot of log producers and custom home builders and all the people who were advertising in Dwell magazine, all of that, the prefab, and I'm like, I'm looking at this as a builder, but as a software guy, I want to build more buildings. I want to have a scalable system. So I want to know how the data becomes a building in your factory. So if you have a new design, I want to know that process. And the pattern I established for wood is like, wait, let me see your machines. Who made those? Where are those from? Which software, what's your path from your design to the machine? And then I said, well, wait, it's all European software too, the CAD/CAM software. Machines, everything, and then a lot of the time there's another German-speaking guy in the back in the engineering room. And I'm like, the pattern is the Europeans are dominant in this, and the majority of these CLT and heavy timber machines and the processes coming from Europe. So what can we learn from them about how to do this better? And that's how I got here, and that's how I originally found Stefan.
You know, the weird thing when you said there, I kind of want to raise a minor objection even though I'm from the outside, right?
Yeah.
So I apologize in advance for my idiocy. It seems to me like a really flexible solution, like the way the auto industry has done it with their robotic arms and things like that, would be more efficient than the way the Europeans have done it. The Europeans have done it this way, and I don't know why.
Strength. I mean, looking at the way that that's done, the arms are not as strong, and it takes a lot of pressure to do that.
So the mechanical is not an issue. I think the biggest issue is, it takes Ford or whatever brand, it takes
the programming of the arm,
probably
right?
2 years or 10 years, and so is Boeing. They engineer and design forever to really, tune that thing.
No, I get
and then
that
they produce.
part.
And we just don't have that luxury. It's like like I say, I've never once produced the same exact building twice. That just
So it's the
doesn't happen.
prototype time of design that's the problem.
We need something that is real-time flexible. It's like we have like very unique parts. And
But you
that's
could do that with the arms. The problem there is not the product.
No,
If I can weigh on this, I completely agree with what Stefan's saying. He's a smart guy, he's right. And there's a place for the arm on this type of process, but there
I'm
are
not
so
wanting
many,
the
wait a minute.
arm.
There are so many repetitive operations on this type of, like the CLT panel. It's
Right.
going to get windows, it's going to get doors. What are those? Those are rectangular holes in a flat panel. If you have a 5-axis arm that's coming in with some fancy thing to do that, you're losing accuracy, and you have a lot of money in that hardware for a repetitive operation. You're much better off with having a 2D, well, it's 3D because it has to plunge, but a 2D chainsaw. It costs a hell of a lot less, it does it faster, it does it just as accurately, and the software is easier. You don't have to interpolate between these 3 or 4 joints.
But you could use a vibrating arm on it. You could use a vibrating arm.
I think it's oversimplifying it too. I think we're missing the point.
You're
though.
missing the point. If you haven't done it, don't go thinking the hundreds of thousands of people who work in these factories haven't thought of the clever
Right.
idea for people
Right.
who've never done it.
It's not that
Don't-
question. I want to understand why they're thinking this way.
Learn German.
Okay, we got to do that. You got to do that in your own
10
time.
years, and then come back and realize they all have the same questions you have.
Over and over
Well,
again,
you know,
you'll
I
hear
just
that,
want to add
that
that
statement.
this is just a robotic machine. If that's a robotic arm or if that robotic arm, that can be a combination of it. There's gantry machines that do have robotic arms on there too. That's not the issue. The biggest issue is way before that. It's the design and programming and knowing where does the hole go and do we need a hole where we have a tool for it and all of that. So the whole thing is, just look at that. A robot is nothing else. Once you put the mill head on it, it's nothing else than a 6-axis CNC machine. So it's this whole mechanical part is figured out. That's not the problem. The problem is design, teamwork, like architecture, engineering,
It's not vertically vertically integrated. integrated. It's horizontal with a whole bunch of disparate tools that hate each other.
all of that. Yes.
It's standard parts is the issue or opportunity. There's a builder, I saw a video from the Netherlands, I'm going to say it wrong, Wonen. Anyway, in 2011, because of their housing crisis, they decided to digitize their business because they didn't have anything else to do partly. But out of that, fast forward 6 years, now they have 2 divisions. They build homes, apartments, they could look like row houses, and they do complete neighborhoods. And they actually, because they digitized, and then they worked really hard with their engineer and build teams, how would we frame these walls, what are the best dimensions, how we do floors, roofs, and so on. And they have a whole division now that's bigger than their old division. Custom they still do, and they sell much more standard parts where the end user can design on their website your dwelling, see real-time pricing. They took their delivery from 7 months to 3 months to contract, and some of the homes they'll now do in 3 days instead of 6 months. Wow. And it's all because of standardizing the parts, and innovation is unlocked with standardizing the parts, because they didn't know that they could put the parts together these ways, but if you limit the parts, people do crazy things with them and make really cool spaces.
That's like Shenzhen more
But
than.
yeah, and all the machine code is done, and you never have to revisit it, right? So anyway, and the price goes way down, and the speed of delivery is a lot faster.
So do I understand right that you have like BIM object libraries that you use for the standardized parts?
They do
Or-
proprietary to them. Yeah, they've designed their whole business. They just were digitizing their business and trying to figure out how to do it faster. But what emerged was if we standardize these parts, and now these homes are demountable. I mean, they're taking it to
Demountable?
what all would you do, and then they take neighborhoods and take the technology. Now that they've got their systems in place, they load it in the cloud, and they're net zero, they model with views, open space, the 6 different criteria, and they'll just run it in the cloud and then use a human partly to narrow down to the single best solution, integrating several criteria to do a complete neighborhood of net zero homes. Anyway, it's crazy what they're doing, but it all starts with objects and standardizing objects.
Thank you for the insights.
Wow.
Yeah, that's what I think. That's my big realization. The whole people all over the world are trying to solve similar problems. The most innovative thing they can do is figure out other people trying to solve the same problem and how have they done it, and then
Right.
localize that for our market.
One last thing, for me, I keep saying, what they're saying is wood, and for me, that could just be pipe. It's the same story, like you said, it's identical story.
It's also not a technology problem. I think that's the main thing. That this stuff is all here, and then there's people that know how to use it, and some of the stuff isn't easy and painful and limited, but it's here, and people are doing it in Europe and here. So that the problem is before the technology, basically.
And I think that's so we've discussed that at length. Switzerland is not known for being a cheap place or a sloppy place. The point being is they can export a lot of product and technology with really high cost of labor because they've digitized so much. In export with those high cost of labor, the same with Germany. It's not cheap labor, or Scandinavia. But if you're that digitized, you can essentially, you can be very profitable and raise your productivity. So that's my argument here too. The only way we're going to solve the tech problem or the productivity problem is essentially raise productivity by using better software and better processes. Then we could be exporting houses. But not everyone agrees. But let me go, just to finish this slide, thank you for this great conversation. That was my whole objective of this meeting. Did want to show another thing. This is a project, Stefan can tell you about. That's a 10 stage. And the reason I like to show that, I will show that. Some of you haven't seen that video. Let me just show that quick. This is short, it's only 2 minutes.
Trying to get the picture.
Wait, just a second, sorry about this. Remember, I told you in advance, this is a 2-minute video, so I'm going to tell you more, but this is what technology takes possible. You take wood, and using technology, you can deliver this. You want to tell them?
Yeah. Well, what it is it's an event project. It's a temporary setup inside an existing building. It's the Vancouver Convention Center. So we had, in a really short time frame, we had to mull up something that was an architectural ID, basically cloning a Shakespeare theater seating setup. And there were like metal solutions. We talked about CLT, and in the end, that was the answer. It's like a modular wood frame, timber frame type. So the whole thing is a big U, and we did like almost like slices, like pizza slices, like 3-layer modules, the front and the back, and then an upper one. And the nice thing with the wood is wood is really strong and it's really light. So the loading on the existing building was an issue. We couldn't do CLT just because it was too heavy, and so was steel. And the other thing which was great for us, and that's kind of why we get to do a lot of event projects, we can pretty much mull something right away and then just cut it like the same hour pretty much. So wood is really flexible that way. I think we have, most, there's steel fab shops, they can do that too, but it's a little bit more involved, and you have to paint it afterwards and stuff. And so 12,000 glue lamp parts, everything pre-cut. In our shop, we cut the whole thing in 4 weeks, 2 shifts and 2 machines. We sorted all the parts by, what machine does what the best. We had the simple machine that was really fast, and we had a more involved one that was slow. This whole thing got set up in there in like 5 days, same thing, 24/7 install, and that's including a lot of lighting stuff, audio, video, carpet, finished stuff. So it was a pretty cool project, and that got built once, and then those modules would be hauled out and they're stored somewhere. So this is happening again this April, I think it is, or March. So it's like every year they take it out. It was a 5-year contract, and the whole thing was designed for 5-time use. So this year is year 5. Love to do another one. They decided to keep what they have because it was like took a half a forest to do it. No, we had like the 12,000 pieces. It ended up being, I think, 12 truckloads of material fully stacked, and then there were like 120 of those cages or boxes, and so there was 120 trucks inside.
Where did you store it between events?
Near the center, because that was a cost issue. It's in Vancouver on a Sias Island, just when you go over the big bridge in Delta.
Should have like rented, in between the major events.
Yeah, storage and maintenance costs of that is expensive. It costs a lot of money to attend TED, and they decided that's what they want. We were very happy to do it. It was a really good project because we did this whole thing in 2.5 months. And right now we're doing a CLT passive house, single family residence, 2,200 square foot, very small. I've been working on it for a year or so. And it's still like we need to move this a quarter in, we need to move that, and we're not sure. And then by moving this again, changes the whole engineering and introduces moment frames and all kind of crazy stuff. Here, the event construction, and I didn't do that. When I first got introduced, it was like, forget it. They had all those crazy plans, and it's like, well, it's fun, this is the event world. And the nice thing about the event world, they know like TED is happening March 1st or whatever it is. We need something, make it happen. And so there is not like, well, we need to think about that, and maybe next week we meet again and stuff. It's just like, let's decide right now. So we did a fully integrated approach. We had one of our engineers there for wood engineering. The convention center had a structural engineer. We were like 2 3D modelers, so we split it up, and we just kind of developed that as we went, and we were still designing when we already started cutting, and we basically dumb it down to like 4 different cross sections. So there were small sticks and big sticks, but we didn't have like 250 different cross sections in 5 appearance grades and different strength grades. So there was all like the same appearance, the same kind of wood, and so by doing that we're able to order wood way ahead. So they were laminating full lambs in 60-foot lengths. So that just made it a lot easier. Yeah, she has a question here.
I have one question.
Yeah.
Just leaping way into the future, but as generative design becomes more common and maybe the industry standard, then the buildings can be like any shape that the computer generates or the architect decides it to generate. So how is that going to challenge this technology? Because then basically the geometries can be very various, and you can 3D print metal and concrete, but you can't 3D print wood.
That's not true. There's people that do that. Yes,
I have an answer to that too.
Okay, go ahead.
So I was on it like 5 years ago, but maybe it was only 3. They used a genetic algorithm to take a look at a tree, and they broke the tree down into the various components and then found the pieces to fit. So this was a very organic object that they did, and they machined it down with the least waste, and they all fit together like Japanese joints. And it was just like, oh my God, it was just this beautiful thing, and it was amazing. So
even that's not a challenge.
So basically you can do generated design like if you go to Autodesk University and you see like the crazy flexible dress and the Airbus wall and all that kind of stuff. But that's based around, they understand that they're printing anything they want. They can do that, but you can build constraints into the generative process. You can say, make straight connections where one piece meets another, do this type of joint, do that type of joint, and you can build that into the generative process and work it out.
But for that stage, it would be like, we need butts here and here and here, and it will generate it out.
Well, for that stage, you want to do generative design, you say, Stefan, generative.
Yeah, do it.
And then,
Yeah, I don't know. I mean, the 3D printing of wood, that's a whole other thing, but that's coming too, and it's not just to it. But that generative design and all that, that's all great. The way I see it, and I think I've done my first course about that about 10 years ago with Bentley, and I was like, oh, this is so cool, until we had to script it, and like 4 hours later we're still working with that same triangle, and I'm kind of thinking I would have built this thing 100 times by now, even by hand. But that wasn't the point. I think those organic shapes, it's fantastic, but it only really works if you also add like a smartness of like building code checker, like, okay, now there's a flag, this doesn't work because it doesn't match code. If you add engineering software to it, and nobody has a software right now that does all of that, even for really basic buildings. Like I'm talking just a stick frame wall, something that the only industry, and I may be wrong in that, but maybe you guys know that better, but the truss industry, those are the only ones where you can say, okay, here's a span, here's a roof slope, and this is where it's at, and this is your roof loading, and then it spits out a shop drawing, a machine file for a truss and the plate design. But nobody has that for a building like this or for something relatively simple. So I think before we do all the weird organic shapes, we need to figure out all that smartness for just like, linear shapes, honestly, like rectangular parts. Yeah.
So I actually built a prototype to try this out on something, right? Linear shaped buildings. And I stopped because I was like, well, now that I can have a computer generate a linear building, who the hell do I sell this to? Because it doesn't make any sense to do small, 40 by 60 buildings, right? And so I think the problem there is the insight I'm trying to imply here is that if you did make such a simple program, you'd have no way to sell it.
I don't know.
The builders are too big. They want something that is bigger. And the people who do small buildings like houses or something like that, they're not interested in this stuff. They'd rather hammer and nail.
Yeah.
right?
I think if you'd have that for regular buildings, that would be a huge market. But there's also the problem of localization. You know, building code is, Seattle is different, and I'm sure Ballard has some extra pylon, and most likely that's not just going to come somewhere from Europe, and they're going to say this stuff is all stupid here.
Just don't build in Bellevue.
Yeah. California.
Yeah,
No, but
California,
that's-
Hawaii, much
Yeah, so there is, once you take all those difficult things away, then in the end, but you have Kansas, and there it doesn't matter, you can just build whatever you want anyways, right?
And I think to go back to where I'm material agnostic with digital fabrication, people are like, wow, 3D printing is going to come with generative design and you guys are all going to go out of business. I'm like, wait, the guys who know how to take bits to atoms and tell the machines what to do are going to be the first guys to 3D print the buildings.
Yeah.
Because the other people who only have design that don't know how to code machines won't be able to do it. You're just changing the head. It's subtractive, formative, additive. One more argument to use more technology. I'm almost done. Loving this. I just want to show a couple more projects if we can. That's a CLT project we worked on in Portland. You guys probably have already had a chance to read that slide. This is an interesting thing. If you don't know, the Oregon is building a really big $65 million complex. It was called this, the National Center for Advanced Wood Products Manufacturing Design. I love that name. And they're dumping that $65 million into it, and they're building a really great building. But they've changed the names, but we're involved in that project. Yeah, but here's Oregon's doing a lot of things. Here's some of the buildings. Some of the companies in the rooms are working in various ones of this, but I do want to say there's a lot more than even this, but a lot of us are under NDAs, so there's a lot more coming.
And not just, maybe just real quick, not just in Oregon. I mean, all over, like I said, was just in New Zealand, Australia. This is really going up. Europe is really pushing, the UK. Although the UK isn't traditionally known for being like very wood friendly, they're really embracing that.
Why is Oregon ahead of Seattle?
Their governor. Right, the governor's green, well, that's one thing. That's a big supporting factor from the top down. I think they're getting a lot of a regulatory approval. Any opinion?
I think there's just initiative there. Those 3 projects there were just people-based. They weren't driven by the governor. So
but they still have to get permits.
So that's a good point.
Well, most of those do have permits.
Right.
No, right?
Right.
No, but that-
University
no, that's a
system
good
has a lot to
point.
do with that, right?
Yeah.
The research in Oregon has a lot to do with it.
Yeah.
It takes initiative by individuals, and then it does take, in the case of Oregon, the Building Codes Division at the governor's direction came out to the industry and said very emphatically, if you want to do a mass timber building that doesn't meet the code right now, we'll work with you. And so that was different.
But that could be.
So is that not the case in Seattle? If I want to
It really is the case though. The government here is really responsive.
No, it's not the case right now.
Really, I found like I've talked to the city of Kirkland about making code changes or CLT, and they were totally like, yeah, we'd support you. And that's the city of Kirkland, a small little town here.
Yeah.
Like,
Might get better there.
But I think that's within reason too. Like there's like the 5-story existing.
Right, there's the whole 5-story UBC.
So you can do CLT within that.
Seattle isn't
but-
against it. It's just a matter of Seattle's a very large city, and we love process in Seattle. So we have more process in Seattle than you can shake a stick at. And I have heard from people in the city that no, they're all for large wood structures. They're waiting. The 2018 code's now out. It's not adopted here yet, but it's out. They're looking at Portland. They're kind of on the general plan. But it's going to take somebody who says, I want to build this building in this location, because the code is just the minimum. You can always say, instead of the code minimum, I want to do this, will you accept it? If you give them the engineering numbers, and you give them the stack of paper, you can do anything you want to do. And they're not generally against it, but there's a lot of process involved. I submit for a permit today, I'm not going to have it for a year.
No, I worked on Susan Jones' CLT project here in Seattle, and exactly what Mark is saying right there. They'll work with you if it's more stringent, but it is the processes that go into it. I would like to also throw this out to this group right here. I do know that a year ago there was a push in this city. There was 2 legislators that tried to actually push through the state of Washington a CLT requirement that every single public building in the state of Washington would be built with CLT. We got this thrown in front of us when I was working at Selling Construction with the sustainability department. We're like, You can't do that. That's just unpractical. So we have to be very conscious too on what's practical and what's unpractical when we're introducing these to our actual city agencies. We can't just be like, go for it. We got to find our opportunities and pick at those. And then eventually we'll start to snowball. But the idealism can also hurt us too, as we're sitting in this room and getting all charged up about mass timber and stuff like that. Let's also realize we're the educated people. We have to educate others.
Could you talk more about the university systems? You mentioned.
Yeah, so I've been on this advisory board in Oregon, and there's a program where the Oregon legislature sets aside funds for startups in Oregon, and this was started, I think, back in the depth of the recession. And the idea was they would fund a startup if the startup partnered with the university, or it was the university partnering with a company because they had IP, and it was about creating jobs in the state in Oregon. And I don't know, probably 2 out of 10 proposals we looked at were from the wood industry around heavy timber and research in the universities to further this in Oregon.
Yeah, they went to Douglas County for that CLT plant that they went to, a depressed area that needed the work, and it was really easy sell for the governor of Oregon to say, let's give this grant to this area.
400 jobs there.
Yeah, and in a place where, like, I mean, Roseburg, Oregon, Douglas County is like a famous place for logging in the United States. And to actually get like conservative people in the United States to accept something like this, I mean, and I don't want to say they tricked them, but it's like, hey, here's jobs. Opportunities are all over Washington right now for like giving more jobs to these depressed rural areas around here that need it. So, you know, it eventually, that law that they tried to push through in Washington, where we couldn't produce all this CLT to meet this initiative, we start like getting the capacity going around here, then people would be like, well, this might actually be a pretty good idea. Horse in the cart.
So how do we get incentives for, you know, CNC and that sort of thing for like high school students who maybe don't want to go to a 4-year college? Washington should actually support
There's a lot of
that sort of thing.
No, I mean, there is a lot of it, right? Like Washington Tech has a program.
I'm sure there is. I don't know enough about it, but I think that's where we're going to get that.
It's getting
boom.
bigger with the 3D
There's not
printing,
enough
'cause-
people wanting to do that.
Yeah.
So another group I help is called ACE Mentors, and we're starting an ACE for the trades, but
ACE.
we're also looking for the tech side of the business. So we're going to be advertising next week at Franklin High School to get students who are probably not college bound, to know that construction is not just about hammers, it's tech.
Right.
And that there are great careers out of high school with some technical training.
It's like there's this mystical veil over it.
Yeah, nobody wants construction that's not sexy.
Well,
I mean, literally,
It's true.
in high schools, you know, if they're college bound, they're not worried about it, and those that this industry could attract and need, we're not on the radar as an industry.
Well, we're on the tail end of all this, you know, STEM this and STEM that, and you have to get into this, and you have to compete in the world market, and we've completely neglected the trades and apprentice programs and things like that. And I think that's starting to turn around. I see it in other industries. I see it like in automotive.
But this is-
There's a huge shortage of airplane mechanics, for instance. So that industry is starting to really make a lot of noise. And I think that we have to be smart and do the same. And like you said, it's like, hey, construction is actually tech.
Let's make pretty buildings. Exactly.
Did you have something to say? What was there?
I wanted him to have the chance to finish what he's saying.
Oh.
There's another thing I want to bring up. I think another opportunity we have here in the West Coast is the tech companies, their campuses and their employees. Got a lot of money. You want a fancy big house with a cool design? We've got a lot of high-income people. Plus, you know, the Microsoft's doing the CLT. And I read through the Google Sidewalk Labs, the 196-page report they're doing at Toronto Smart City. They said the whole future is all prefab modular CLT. And the standard they want is passive house. And it's right on the report. And I'm getting calls from let's call it tech communities, and people from the tech industry, because it's a lot easier if you have Microsoft and Google on your resume. Get your construction industry company funded. I'll give you an example. Blue Homes, $200 million, BLUHOMES, shut down their production of Viejo now because they can't figure out how to build a house. Most of that money's gone. 200 million, blue homes. But hey, they came from MIT, they can't figure out how to build a house, right? So what happens is you're getting a lot, because of the hot housing market, we're seeing a lot of venture capital flowing in that want to essentially figure out how to prefab homes. But when those people are calling, but what I say, well, you need construction industry experts on your team and technologists. But too often they don't have construction industry people, they only have engineers. And I'm like, you still got to know how to figure out how to build a building. Because that's coming from Google, that's coming from Microsoft, because they're seeing the shortage of buildings as it's an impact on their ability to hire employees. So I think we have this opportunity because we're here. When I'm over in Europe, for example, in Finland, they're like, you guys got everything. You got Amazon, Microsoft, you got all the wood. You've got people who will take risk on new things, maybe more than we do. So what are you lacking? Or when I was in Germany in April, as I said, they've got that massive market, all that timber. You've got those unemployed people right in the middle of this big forest. You've got record-setting housing demand in Portland and Seattle. What are you missing? So I don't think it's a demand problem. This is another thing I wanted to show you quick if you didn't see this announcement. World's largest wood building. Just got announced. I want to work in a building like that.
Yeah, is it funded?
I
read your whole article you sent today. But...
Yeah, what is it funded mean? But
does it have money to build it?
It's virtually funded. I think they said 2020.
What's a Bitcoin?
But there's a lot of crazy stuff. But at least I think a lot of the tech companies and startups want to put people in a healthy, cool building. They don't want to attract that talent. And I think the T3 in Minneapolis, right? That was a very successful wood building. So I think the tech industry can be customers and partners. And we're fortunate that we live in such a tech hub. And this came out, I think today, January 4th. And obviously, my wife's from Finland. I work with this Swiss guy here. I think the fastest way to go forward is collaborate with the Europeans on what they're doing and lessons learned. So it's not just about making CLT or another wood product. It's like, well, how do you make money? Why is it good business? And my lesson from the Germans and Swiss and the Finns was like, they're not using technology because it's fun. They're using it because it's good business. You can build better, faster, cheaper. You can do cool designs. So let's collaborate with them.
But it is fun.
Well, it is fun too. It's more fun. But that's obviously what I want to do, and I hope that's what I think how we could thrive here. I think we could. The Canadians are getting a lot more government funding for this than we are. They're creating a market like that. Brock Cummins, the government is creating the market and funding a lot of the research. But the way I think we can go ahead cost effectively is partner more closely with the world leaders and learn from them and work with them. We shouldn't get in the business of making the machines. We should get in the business of using them better and localizing it. That's just kind of my view. What I want to ask then is this question. Going forward, you're all very busy in a record-setting construction market. So am I. The reason I started this meeting because no one else set one up. So I said, well, I'll cover these topics because they're of most interest to me. So why don't I invite people to come? I have a lot of people who do want to speak, again, from different countries about where this industry is in their country, and they want to connect with Seattle. So I was thinking we would have a presenter or two at the monthly meetings on the topics, and then I would like your input, and I'll send you out a survey, a very short one, on what would make these kind of monthly meetups most relevant to you. It would be worth your time to come. So if you could discuss that, contact me. I think we have an opportunity here. And people aren't going to agree on software, they're not going to agree on machines, they're not building the same type of buildings, but the people who believe this is an opportunity, they want to do it, I want to work with them. I went to too many meetings where I thought I had a great solution, but the person simply wasn't interested. If someone isn't interested in building this, or like, hey, I'm making plenty of money building the old way, you're kind of wasting your time trying to convince them. So ideas or thoughts, send them to me and discuss, and I'll try to set up a good meeting for next month.
Thanks, Greg.
Thanks, Greg.
And Stefan.
Again, I'm sure you'd take some help setting that meeting up.
I get a question for you.
Yeah, Heather kindly offered this wonderful
Yes,
space.
thank you, Heather.
to inquire, I think it would be good, I think we're going to the next one, Edmonds Community College next month, and I think it is beneficial to move this meeting. I would like to maybe use this if it's available in the future, but I think there are benefits to exposing us to different companies if we move the location of the venue.
Yeah, and the next one we might try to actually deploy techniques of how you do prefabrication.
Yeah, and there's a big topics, right? There's a lot of things we could cover.
So an actual technical.
An actual like demonstration.
Let's meet at the fan shop in a couple of months.
You gotta bring those
Down
guys.
in Portland, let's meet.
Can
at
we
the fan
actually
shop.
get into a shop and see some robots cutting some wood?
Yep.
Well, I was thinking like a smaller case. But I mean, that's up to Stefan, you know, I mean, getting like a larger scenario. But I was thinking like a scale model.
Sure.
We have
And
VR.
then using, you know, potentially like
We do that. I
tree
can bring my gear.
fabrication,
Yeah.
we could 3D print stuff.
Can you bring a PDA machine up here?
Sure. Tabletop one. That's the beauty of it. I mean, I really wish Hyundai would make a demo machine that is like a 3x3 format that doesn't cost a fortune. In the end, this is really the same. The movement and the code is the same.
What would you use it for?
I do have a question for you.
Yeah.
So is your machine busy 24/7? If it's not, if it isn't, why not?
Ooh, that's a good question.
And
So it's a
What?
pretty easy answer.
What's the
No,
question?
it's absolutely not.
24/7?
Yeah.
Yeah,
I
no.
wish that would be one.
so can we rent it?
No.
Build its own awesome.
Crowdsourcing CNC machines.
Well, that's what
He wants to do his project.
That's kind of how I started my business. Like when I used to be a software guy, and then I got to meet all those people with those machines. That was my same question. Every shop I walked into it, or the machine wasn't running. And I was like, well, why is that? I also knew what these things cost. And so that was a kind of in a downturn economy. And so my idea is like we can do 80% of the work with 10% of the overhead, basically, by doing all the thinking and the design and the coding and ordering material and having stuff there in time. And then I talked to a bunch of people I knew. It's like, hey, if I want to rent your machine by the hour, I'll just bring your file to kind of use your machine. And that's how I ended up in Portland. I found Tony Polcharski. I just bought one of those Humdiggers, and he's like, sure, yeah, whatever, that's cool. And so that's kind of how we started. And my idea was also, just like you know, one guy's an architect, the other person is an engineer. So those machines, they're all unique too. Some of them are really big, but they're slow, they're limited. Others are smaller, but faster. So you want to use the right machine for the right application, but the trouble is you can't have 10 machines because they cost too much. The idea is if you have a whole network of that, then you can just pick the right machine for the right job. And that's what we did with TED. We had a fast, small machine, and we had a bigger, you know, more universal machine. And that's what we're still doing between the two machines we have. But yeah, so we're not 24/7 busy. The bottleneck is clearly the design, figuring all of that out. And then there's also material in and out. It's typically the machine is a lot faster than we are. You know, those beams come out, we have to clean it, we have to wrap them, we have to test fit it. So there's a lot of pre-assembly time that goes in as well. I wish we had a job. We're looking at it right now. We're looking at some development in Hawaii where I think phase 1 is 150 like cabanas, like small little cabins, all like cool timber. And so that maybe if that's going somewhere, that may be the first time where we could just 150 times do the same thing. And then we would apply more of automotive, you know, type thinking, or just say, okay, today we're cutting valley rafters, and then we're just going to do 150 left side valley rafters and stuff.
I'm going to ask to this question. What is, you're talking from economic terms, capacity utilization. How often is the machine turned on? Because everybody who owns a machine wants to keep it turned on, making money. But a lot of machines, and then because the machines record everything, you can actually see an accurate count of its capacity utilization. So that's why I would ask him, like, all right, what's the capacity utilization in Switzerland of these machines? And the reason I think their market is more mature, this is actually available on the Cut My Timber website, it is more mature because are you using sketches and 2D data all the way down to this page where you're actually submitting CNC code.
Right.
So you have more of the design community that is delivering to the fabricator that level of data, which is, this is really complex, but yeah, it's a...
Just to give you an idea too, in terms of timing, from here to there, like hour-wise, that's probably, I want to say, a factor 10 compared to the machining time. Or with other words, if I'm on a machine 1 hour running a machine, I'm probably sitting on a desk 10 hours, meeting with engineers, with customers, with architects, with recoding, rechanging. And again, it depends, not that every component, but larger projects like the one we've seen here, that's clearly a factor more than 10. So the machining time isn't as relevant. Everybody sees in the machine the answer, but the real trick is not the machine. That's like the whole front end of it, people underestimate. They think, oh, these guys are cool, they have a machine, but really the cool part is what's happening before the machine. This is just an executive thing.
Well, so that's a great segue into not so much a question I was going to ask, but a statement I was going to make, and that given we have to deal with what we've got. So the ideal world may be a terribly integrated design build thingy, one big happy family, kumbaya, we all build these wonderful buildings. Well, that's not the world we live in at the moment. I work for a design firm, we don't even have engineers. But one of the things that designers can do if you make them kind of pony up and put their big boy and girl pants on, is they can deal with constraints. So we've had a couple of people come to our office and talk about large-scale wood. But they just talk about the fact that you can build it really high and have it structurally work and not burn down, provided you cover it all up with gypsum board. And that's about as far as the conversation goes. Now I know that the designers in my office and the younger folk in my office are not going to care about section modulus and getting into how well wood bends and doesn't bend and what it does. But if what we could do with the crowd of people in here is start to develop, I hate to use the word a course, but these are the constraints. These are the things that this stuff does really easily. That factor of 10 you talked about. Okay, you have this great idea. These are the things that have to happen before it becomes a reality. These things are going to start to constrain your design. These things are possibilities for you. And so think about this before you start sketching. And as you're sketching something, don't worry that you want to have a curve. You can do curves, but these things have to happen. Try to find some ways of at least, not that you're going to educate them all the way, but get them introduced to things that can affect their design. So get them excited about the process, excited about the opportunities, and so when a developer comes to our office and says, I want to build another building downtown Seattle, I think the CLT thing could be kind of cool, the designers say, yeah, but it's not just get the machine. We have all these things to do. They won't know all the answers, but they'll know the buttons that have to be hit. The designer will be seen as someone who's educated in a general way about the product and process, and they'll have some names to go with it of you need to talk to people that can actually mill this stuff. Oh, we want to hire your firm because you folks have some feeling for it, even though we may not have built one yet. But getting those buttons, those bullet list points with enough explanation or a little piece of video or a little demonstration behind them can help sensitize the design community, because most of them are not part of design build integrated firms that deal with wood. Just an idea, but I think that could be a good thing to spread the word.
We already do that to some degree. I mean, we always have an open shop. People come to us, they see the machine. When we start working with a project, we try to, we always push a code like machine-friendly design. And so we're doing that. And I think, we didn't really talk about money and the economy and stuff, but I really think there is a lot of savings. Like a big problem right now with CLT buildings we have, it's all more expensive than a conventional building, and then that's when the project dies. And I think by addressing certain things early on,